Let's take a look at the law of sine. I already have a triangle here. We're using the law of sine if we do not have a right triangle relationship where we can use opposite, adjacent, hypotenuse. We use the law of sine to find all the angles in the side of an oblique triangle, aka no right angle here anywhere within my triangle. And the law of sine, I already stated it here, is really where you set two proportions equal to each other. So side A over the sine of angle A is equal to side B over the sine of sine B, which is equal to side C over the sine of angle C. Or depending on what you're looking for, if you're looking for an angle first, you can flip it around and it's still the same relationship. So let's do a problem here. The angle A is 102, C is 16 degrees, and side A is 21.6. It's always a good idea to draw a picture. Okay, it doesn't, of course, have to be to scale, but I was trying to get a 102 angle. Well, that didn't work so well. But let's make this A. Here you go. Here's A, which is 102.4 degrees. Now, opposite, be careful. That's why it's so important to draw a picture. Opposite of this angle has to be side A. That means 21/6 is right here. Let's put C, let's draw C right here, which is 16.7 degrees. That means side C has to be opposite. And then we have B over here, which side B is opposite. And we want to find the missing angles and the missing sides. Well, the easiest way to get started here is we have two angles, and what else do we know? The sum of all three angles in a triangle has to be 180 degrees. So it would be real easy to find angle B. B is equal to 180 minus 102.4 minus 16.7 degrees. I do have a calculator now. 180 minus 102.4 minus 16.7 is equal to, so angle B is 60.9 degrees. Here you go. We got all our angles. Now, let's find side C. Why would this side C is easy to find because we have the A side and we have angle A and we have the angle of C, and we that way can easily find the side C. So let me write C over sine of 16.7 equals, and I'm going to use A. I always try, no matter what I'm trying to look for, I try to use the values, first of all, that were given in the problem. So A is 21.6 over the sine of 102.4. So if we solve for C, that now we multiply by sine of 16.7, 21.6 times the sine of 16.7 divided by the sine of 102.4. Let's round it to one decimal place. Also, if you use your calculator, make sure that your calculator is in degree mode. And I'm looking at mine. It's in radians, so I'm going to change it to degree mode. Let me make sure that actually worked. Done. Here you go. Okay, 21.6 times the sine of 16.7. I'm going to press enter then and divide all of this by the sine of 102.4. That leaves me, like I said, I want to round it to 1 decimal place, 6.35. So side C is 6.4 units. Units are not actually given, so we just call it units. Okay, the last side we need to find is side B. So we use the B to angle B relationship. B over the sine of, what was B? 60.9 is equal, and then again I'm using the values that were given to me, so A over angle A, 21.6 divided by the sine of 102.4. You multiply by sine of 60, B equals 21.6 times the sine of 60.9 divided by the sine of 102.4. 21.6 times sine 60.9 divided by the sine of 102.4, and we get B equals 19.32, so 19.3 units. This is one example of a case where we have two angles given and a side to find the remaining values using the law of sine. Okay, let's take a look at this case where we have an angle, and the side given, and we're using again the law of sine to find the missing side. So what can we do here? We can find angle C by subtracting 65 and 35 from 180. So that's the easiest way. 180 minus 35 minus 65. Okay, I guess I could do this in my head too. 180 minus 35 minus 65 is 80 degrees. I knew that. Here you go. So angle C is 80 degrees. Now, okay, I have side C, I have angle C, and let's find A. Doesn't matter which side you find first. A over the sine of 35 degrees is equal to C, 10 over the sine of 80. That means A is 10 times sine 35 over sine of 80 times 10 divided by the, not cosine, by the sine of 80, and I get 5.82, so 5.8 units. Okay, let's find B. B over the sine of 65 degrees is equal to 10 over sine of 80. Now, you could have also, in this case, used side A over sine of 35, but like I said, I like to use the values that were already given to me, at least as much as I can. That way I can catch a mistake. If I made a mistake here with 5.8 and then you use 5.8 to find B, then this mistake carries on. But I use values that were given to me, I may not make a mistake to find B. That's really why I use the values that are given to me. So 10 times sine 65 over sine of 80. You need to use the calculator here, so 10 times sine of 65, divide that by sine of 80. I got 9.20, so approximately 9.2. Here you go. We found all the angles inside of the triangle. Okay, now we're looking at the case where we have two sides given and one angle. And with this case, we could run into some trouble. There could be some ambiguous cases where you try to solve for the missing side and you have no triangle whatsoever. Or you have the case where it just forms one triangle, like using the law of sine. Or you actually, with the measurements that are given to you, could come up with two different triangles with two different sets of measures for each side and for each angle. And that one I want to show you a little bit later. Let's take a look at this case here. We have two sides and an angle. So if I make a triangle here, let's say A is 30 degrees right there, so that is 7 units. Here's angle C, and this is 16. Then we have B, and this would be side B. Okay, now, what kind of relationship do we have, and what should we look for next? Take a look. We have side A over sine of 30, so we can use this ratio. And we know nothing about B, so the next logical case would be, since we have side C, to find the angle of C. And in this case, since I'm finding the angle of C first, I'm going to use my second version of my law of sine. Sine C over 16 equals the sine of 30 over 7. Okay, now you multiply everything by 16. So the sine of C equals 16 times the sine of 30, divide that by 7. Okay, use your calculator. 16 sine of 30, we all should know what that is. 30 is one of our common angles. Of course, the sine of 30 is 1/2, so times 16 is 8, but that's beside the point. Divide that by 7, and sine of C is 1.143. Now, to find angle C, remember, how do we find an angle? We are using the inverse sine of 1.143. Now, as you very well know about trigonometry, a sine has a range that goes from -1 to +1, so there is no possible angle for 1.143. So in this case, this problem has no solution. There is no way we can form a possible triangle here. Okay, let's take a look at another case where we have two sides and an angle given. And basically what I want to show here is that we can have two different triangles with the sets of measurement or information that is given to us. And how do we do that? Well, this all depends on the height of the triangle. If side A is greater than H but smaller than side B, then we can form two different triangles, and we have to find the measure for all of them. So that means the first step is really to find the height, and for the height we're using a basic right triangle relationship. The height is opposite to my angle of 27 degrees, and I have the hypotenuse. So opposite over hypotenuse is equal to the sine of 27 degrees. So to find the height, I multiply 15 times the sine of 27. Use my calculator. 15 times sine of 27 is, the height is 6.8. Okay, so let's take a look. Make sure that we really can form two triangles here. 7 is definitely greater than 6.8 and less than 15. Here we go. So that tells us that the two sides and the angle here actually conform into two triangles. So let's do the first triangle. Let's call it B1, C1, and so forth. Okay, what do we have given here? We have the angle, we have the height, the opposite side 7. We have B given, so let's find sine of B first. So the sine of B over 15, let's call it B1. The sine of B1 over 15 equals the sine of 27 over 7. So sine of B1 equals 15 times sine of 27 divided by 7. Okay, 15 times sine 27 divided by 7 is 0.9724. Use as many decimals as you can. So which angle does that form? For which angle is the sine 0.97? We're going to use the inverse sine. Negative 1.97284. Second sine, I get 76.4 degrees. Okay, so B1 equals 76.4 degrees. Actually, 6, I have 6. Here you go. So that is B. Now we can easily find C1. C1 is 180 minus 76.6 minus 27. 180 minus 76.6 minus 27 is 76.4. They're all the same, 76. Here you go. And we have B. Let's find side C. C is sine over 76.4 equals, I'm going to use A, 7 over sine of 27. So C equals 7 times sine of 76.4 divided by the sine of 27. 7 times sine of 76.4 divided by the sine of 27, and that would be C1 14.98, so let's say approximately 15 units. So that would be the relationship for the first triangle. Now let's find B2. To find B2, we're using the 76.6, where are they? Right here. We're going to say 180 minus 76.6, and that is equal to 103.4. So 103.4 for the angle B2. We still have the 27 right here, which now if we find angle C2, it's 180 minus 103.4 minus 27, and that is equal to 180 minus 103.4 minus 27, 49.6. So C2 is 49.6 degrees. And to find side C2 over sine of 49.6 equals 7 over sine of 27. C2, 7 times sine 49.6 divided by the sine of 27 degrees. And if you do the arithmetic and you use your calculator, you get for C2, I have room right here, C2 is approximately 11.7 units. Here you go. So we get two triangles here with C1, angle C1, we have A and B, and we have both angles. Here you go. That's it. So you got to make sure you have to find the height to see if your relationship that's given to you, side-side angle here, this only works when you have two sides and an angle. You got to find the height, make sure that A is greater than the height and less than B. That way you get two triangles.